Drivers behind the line.
Good evening, everyone. Welcome to Season 4, Episode 4 of Behind the Lines, where we bring the experts to you. I'm Evan Morrison. Joining me from RoboSports Network is Ty Tremblay.
Hey,
this week is all about CAD. Tonight's episode will focus on the what, why, and how of CAD, along with what resources can get you started.
Yeah, if you already know how to CAD and you've got a system that's set up, this will be good for you if you're looking to see what else is out there or how to train somebody else up. But this is a beginner's seminar on where to get started with CAD in FRC, where the resources are, how to download it, etc.
One last thing before we get started. The views expressed on Behind the Lines by the hosts and guests are those of the individual and do not necessarily reflect the views of first participants. And don't forget that you can submit questions to us throughout the show by tweeting at RoboSportsNet with hashtag FRCBTL, or by messaging our Facebook page, or by typing !Q into the Twitch stream chat followed by your question.
All right, with that, let's get started. We're going to head right in here to the presentation. And Evan, you are up.
All right. So you may have noticed that Ty and I are also your experts tonight. We both have quite an extensive amount of experience using CAD, both with FRC teams and also professionally in our day jobs. So without further ado, what is CAD? It's not scary, we promise. CAD stands for Computer Aided Design, and in essence, it's a 3D digital representation of physical parts and assemblies. So before you actually build anything, you can build it virtually. It lets you model relationships between parts, and that includes moving relationships such as pivots, even gearing, etc. And then you can create scale drawings with dimensions to help you make those parts the right size so that it's all going to fit on your robot. At the bottom of the screen, you can kind of see this progression. This is an example from 5803 Apex's robot last season. You can see the part itself is a little piece of box tubing with some holes drilled in it. It's actually VersaFrame. But we had to cut it at specific angles into a specific length. And then you can see that part integrated as part of the larger robot model. And we also have a drawing of that part that tells us where to cut it, how to make it, what angles, and also how many of them we needed to make. And then finally, there it is on the robot, and lo and behold, it fits because we spent all that time ahead of time making sure that the part was designed right and then built right.
Yeah, and I think one of the important things here is that you guys only had to make it once. So being able to design it in software and have a 3D representation to see how everything interacts, it basically allows you to make your mistakes but not have to waste any material or time, or a lot less time that way. And actually, one of the cooler things that you can see about this robot, if you look down in the full robot pictures, you can see that the rear wheel is in the back, and what that actually kind of came out of the CAD during the design when 5803 was developing their robot. They realized that if they flipped their rear wheel to the inside of their drive rail, they could potentially snug up closer to that hopper and trigger that hopper much easier. And that is one of those things that just comes out of playing with a 3D model inside the CAD on the program.
Definitely. And we could go into how we came up with that a little bit later. But even before it got to this point of being a full model and figuring that out, we figured that all out with just Scale 2D sketches.
Which brings us to our next topic. So the most basic set or version of CAD is the ability to make scaled 2D geometry, which is basically just napkin. I don't know if you've heard the term napkin CAD, but it's basically just drawings on a napkin, but in a much more accurate and to scale form. You can see here on the left, we've got 1114's 2008, one of the most effective robots ever created, was done almost entirely, the concept was done almost entirely in 2D before they moved on to 3D. And then third, or additionally, on the right here, you see 2012 robot from Team 67, where they designed they almost don't do 3D at all there, but they were able to come up with this amazing do-it-all arm just from their 2D CAD relationships and just coming up with sketches.
Yeah, the key point here is that you can do so much work and get so much done just by doing scale models, making sure that everything fits in the right location, and making the computer do all the math for you. So if you look at the picture on the right with 67 Hot's arm, right, where they put those rollers and things to grab the ball and how it interfaces with the bumper, they're using tangency constraints there. That's something that just sketching it out, you're not going to be able to figure out exactly where it is. So you might be able to prototype that, but it'll help you get there a lot quicker if you just sketch it up in CAD and then figure out where those dimensions need to go.
Yeah, and I'm sure we've said it a bunch of times already, but the number one benefit of CAD is being able to get all of your mistakes out as fast as possible. And the way to make effective robots in FRC is through iteration, to try something, figure out what didn't work and why it didn't work, and then build something to improve on that. And designing with CAD effectively can really, really improve the rate at which you iterate.
So one of the ways that you can iterate quickly is faster, better prototypes. You can find out what fits without having to make anything. We just talked about Hot's arm and ball collector from 2012 Rebound Rumble, right? If you're going and kind of measuring the ball and making some rollers and trying it out and then measuring them, and moving them again, etc., it can take a long time, even during prototyping, right? You're supposed to be making mistakes then, but the closer you can get with your first shot, and maybe build some adjustments into that, the quicker you're going to arrive at your final solution. It also, if you're trying to do something that Apex calls high fidelity prototypes, so sometimes we don't have time to completely mock up a system that we just have an idea of. But what we'll do is while we're designing the robot, we'll design the system as we think it should be, and then right before we commit to the design, we'll go ahead and build it as quickly as we can out of wood or metal or whatever to the exact dimensions that we've designed the robot to, and make sure it works. And if it does, great. We validated that everything does what it's supposed to. If it doesn't work, right? Yeah, we got to take a little more time, but we haven't cut any metal yet. We're not locked into this design, right? It's much better than getting to week 5 or week 6 and finding out that, oh no, this doesn't work. Like we thought it was going to work, but there's some dynamics in the system and it just doesn't work.
Yeah, a lot of the things that are really important in FRC is like, for example, this past year in 2017, the amount that you were squeezing the fuel when you tried to grab it was very important for regards to how far you could throw the ball or how consistently you could shoot it. And there really wasn't because there were so many variables, there really wasn't any just golden number of compress the fuel this much and you'll be able to shoot it perfect. So you had to have a bunch of trial and error based off of how you plan on shooting the ball. So one of the really big benefits of CADing your prototypes is being able to add in that ability to adjust, say, compression on your shooter if you need to. And one of the teams that does this really, really well is 254. And I mean, they do pretty much everything very, very well. They have a laser cutter, so they CAD all of their prototypes and cut it out of like 1/4 inch or 1/2 inch thick plywood, and that allows them to make very, very fast changes in their prototypes, but also they can build in the adjustment that they needed to try and find that sweet spot.
Yeah. One last thing that's super huge about CADing your prototypes is when you finally do find the thing that works really well, you've got all of the measurements already there. You just have to take the same thing that you have a digital model of and make the final version. But you don't have to go back and do a lot of measuring or guessing and hoping that your final robot is going to be the same as the prototype.
Agreed.
Oh, sorry.
No, go ahead.
So one of the other really cool things that CAD can do for you is weight estimates. It knows the densities of materials and it knows the volume of the materials because you've designed your part in digital 3D. So you can find out how much your parts are going to weigh, and that in turn lets you know if you're at risk for being overweight, or maybe if your robot's going to be tippier than you want it to be or think it will be, by finding out where the center of gravity is. It can calculate the center of gravity of your robot assembly for you if you put all the right numbers in. Some CAD programs, you can literally set every part weight and every part material, and it'll give you the whole robot. Some programs you kind of need to do a little bit more legwork yourself with some of the commercial off-the-shelf components you just have to keep track of manually. But either way, you can sum up all of your custom parts that you've designed, all of the metal that you're going to cut, the wood, the plastic, etc., and come out with a final weight that you think the robot's going to weigh. And so not only does that tell you if you're underweight, but then as you're building the robot, if you start weighing it and it's like, whoa, this is way heavier than we thought it was going to be, you've got something to check back to and figure out if you did something wrong, or adjust at that point as opposed to Swiss cheesing it at the very end because you missed something.
Right. And I think actually one of the things I just realized from this talk here is everybody knows the term cheesecake, but does anybody remember the term like cheese holing, in which you got to the competition and you drilled a bunch of holes into anything that was made out of something heavy on your robot in order to get underweight. And I just realized that's kind of gone by the wayside as CAD has become more and more available and teams have been able to estimate their weight of the robot. Cool little anecdote right there.
I did that in high school.
Mm-hmm.
Swiss cheese, cut a whole 3 inches off of our hopper in 2006 because we were like 6 pounds overweight.
Right. Yeah, and exactly. And that's actually one of the biggest things that CAD can help you with, is you can have fewer mistakes in your designs in terms of being overweight, or can we get this fuel from the ground to our shooter wheel, or can we basically, does all of our subsystems fit together? And that's one of the biggest benefits here that we see here of CAD, is we can do all of your integration of your subsystems digitally so that you don't have to go through and make those last minute panicked iterations when you find out like, oh no, the drive team forgot to add, didn't leave this spot open for the ball path when we were doing our designs. And then one thing that you'll notice later on is that you can make drawings of your parts, which makes making the parts a lot easier, because all of the CAD programs come with a really easy way to just make drawings of the parts that you're making, dimension them all out, easy peasy, and then print them and send them off either to a machine shop to get made, or to hand them to the person right next to you to head over into the shop and start cutting them up there. And then one of the side benefits of making all those drawings is you can keep them, and you can then bring them with you to a competition. And if something happens, you just whip out your little piece of paper with your dimensions on it, whip out your stock, go to the machine shop, and you can get something made a lot faster rather than, as we said before, this napkin CAD.
Yeah, and we actually experienced that last season. On Apex, you can see the intake crossbar right above between the sets of wheels and the front gap that sucked up fuel. Well, it's there to protect the intake from damage if we took a hard hit. It did its job. It protected the intake, but it also got really busted, as you can see in the second picture. And this was I think the second time that it happened. So we had one spare, but we knew that if we lost that one, we wouldn't be able to intake fuel anymore. And not only can we not intake fuel, but if we have to take the fuel intake off, we can't even hold any fuel because it all spills out the front. So fortunately, we had the stock material with us, and we had our binder of drawings, and we were able to take it over to the machine shop and just have them make us another one. And it was, fairly quick and easy. I always advocate for having spares at competition, but sometimes when your spares start getting used up, you don't necessarily have time to do a redesign right there to make it stronger. You just got to have enough material to make it through the competition. And so being able to quickly make that stuff is really awesome.
Mm-hmm. All right, so now that we've proven to you that CAD is very, very important, Evan, why don't you tell us a little bit about what we're going to need to get started?
So the two big things that you need is a computer and a mouse. But you can't use just any computer. Most of these programs are pretty resource intensive. So you're going to need a decent processor, and pretty importantly, you also going to need a fair bit of RAM. And a good graphics card, especially a dedicated graphics card, is really recommended. If you're on a desktop, it's going to have a dedicated graphics card most likely. Laptops, that can be something sometimes harder to find. Not every CAD program needs this, but it's going to really help make everything run better, especially when you get to more complicated things. Do not try to track CAD with a trackpad. Use a mouse or a space ball or something, but just don't. Trust us. I even was considering doing a live demo tonight, and turns out that I don't have enough USB ports on this laptop to hook a mouse up and my webcam, so we're not doing that because it's just not worth it.
Yep.
And then
you want to get frustrated with CAD and almost not want to do it ever again, then try to CAD a robot without a mouse.
Yeah, no, you definitely need that functionality. The mouse is how you navigate around the 3D digital workspace. And as you can imagine, navigating 3D virtual space with just a 2D trackpad and a couple buttons gets really hard really quickly. So the mouse is the way to go. Or if you want to get fancy, obviously you could use a space ball. They make 3D mice, turns out, specifically almost for CAD programs.
Mm-hmm.
The other thing you're going to want is internet. For a lot of these references and resources, having an internet connection to be able to watch tutorial videos, etc., is really super helpful. And then, as we'll talk about later, some of the CAD packages need internet access to function, and especially if you're using any kind of versioning software to keep track of what parts have been updated by who, you need internet access to be able to do that. And at the bottom, we've got an example of, I just pulled up Autodesk Inventor's 2016 minimum system requirements. Windows 7 64-bit, Intel or AMD 2 gigahertz processor, 8 gigs of RAM, and 100 gigabytes of hard drive space. That is the minimum that they're saying their software will run at. So already that's a pretty decent computer.
Yeah, it's a pretty decent computer, but as the days go on and as Moore's law continues, then this is still only like, maybe like a $400 or $500 computer that it takes if you have to go out and buy it and you don't have it already.
Yeah. And then one piece of advice I'll give if you're looking at buying a computer to be able to handle CAD, check out gaming laptops. Are something that we usually look for because they have a lot of the same requirements in terms of having a good fast processor, a decent amount of RAM, and they usually have a pretty good screen on them as well, which screen resolution, and it's not mentioned here, but it's something that a higher screen resolution is going to help you out as well.
So now you want to use CAD, you have gone out and you've gotten the computer, but now you're like, now what? How do I actually go about using this CAD program here? So most CAD programs have built-in tutorials, which is very important because everybody, or all of these CAD developers, all the CAD programs like SolidWorks and Autodesk Inventors, they understand that it's the barrier of entry is the ability to use this program. And it's not like it's not like Microsoft Word where you know that you can just type in the words and all of a sudden you're creating a document. It's a lot more complicated than that. So they have built-in tutorials that you could follow that will show you how to use the user interface of the CAD program as well as how to make basic parts. Now, the number one resource that you should be going out and using is your mentors or other teams' mentors too. Everybody's willing to help you. If you have a mechanical engineering mentor on your team, they've used a CAD package. They're all pretty similar in terms of making sketches that you turn into parts that you put together into assemblies, and with the 3D interface, moving about, some buttons clicking here or there are different, and some of the names are different. But if you've got a mechanical engineering mentor that has used CAD, then they can help you figure out how to use the CAD program that you want to use. And we'll go over all the individual CAD programs later. So next, if you aren't able to find a mentor and you've finished all the tutorials, then YouTube. YouTube is basically the tutorial center of the world at this point. You just log in. Don't even log into YouTube. Just go to YouTube and search for what you're trying to do, the program you're trying to find, or the program that you're trying to use, and then the word tutorial, and I'm sure somebody has already made it. And then we'll get into more resources in terms of how to use CAD and ways to make CAD easier for you later on in the presentation.
So one of the biggest hurdles that teams will very quickly come up against when starting to use CAD is how to integrate multiple people into the CAD environment. Version control is really, really important. This makes sure that every person that's working is working on the same files, the same set of files that were created at the same time. And it's very similar to version control for software. So to get an idea of why this is a problem, let's say we've got Billy over here, and he's working on the CAD model. And then Jane's over on her computer working on the CAD model as well. And Billy decides that he needs to make the drive base 2 inches shorter in order to fit some mechanism, right? And so he changes his CAD file to his CAD model to do that. Well, unless Jane is using the same physical or the same file that Billy is, hers isn't going to update, and so then she's continuing on designing parts assuming the drive base is 2 inches longer than it is, and then they go make the parts and they don't fit. So or I mean, hopefully they find out earlier than that when they try and combine their two versions, but sometimes they might go make the parts and then find out. So there's a couple different options that are available to teams, and we're kind of ranging from simplest to most specific or most advanced here. Option 1 is just cloud storage, right? Google Drive, Dropbox, someplace where you can dump files that everybody can access and open a copy of the file that's the same for everybody. They're simple, they're free, but they can be really slow to update. I remember when I was working with Skunkworks a few years ago, 1983, we were using Dropbox, and sometimes it would take up to an hour for files to update. And so what that meant was, like, yes, everybody can use the same stuff, but you had to be really careful that you waited until all the changes synced before you could use it. Otherwise, we'd end up with conflicts, and then we open the model, and the model doesn't work anymore, and it throws all kinds of error messages at us left and right, and then we have to spend a lot of time fixing that.
Yeah, if you have a small team that only has a few people, working on the CAD, and you can actually just communicate with each other, like, okay, I'm going to work on the drivetrain, and so is going to work on this and that. Then this is probably your lowest barrier of entry setup, except for what OnShape does, which we can get to later on, which we're going to get to in the next slide. But yes, cloud storage. It definitely is the easiest way to get started, but if you're not very careful, you can get into some pitfalls.
Yeah. If you've got a small team or a small group that's working on CAD, or if you've only got like maybe one student or two students that are working on, but you have a lot of people that want to be able to view it, the just regular cloud storage is probably a good option. Option number 2 is GrabCAD. This is an online service that's popular among many FRC teams and works with many CAD packages. And it's kind of like cloud storage specifically for CAD. That's essentially what it's designed for. So it takes into account certain things that CAD users really are interested in, such as the ability to check out files. So you can say, I want to lock this file, I want to check it out because I'm going to work on this part, and I don't want anybody else to make changes to it. And so, that reserves that for you and says that you're working on it and checks it back in. So they'll have that option. And it's just it also has an integrated online viewer, so that people who don't necessarily have CAD installed or installed on the computer that they're at can go and look at what's being done, even though if they can't edit it. So that's a really cool option. I know Spectrum and a handful of other teams use GrabCAD and really like that option. Option number 3 is server-based. So now we're getting into a pretty high barrier of entry. Somebody on your team has to be willing to set up, maintain, and run your own server. But there's a lot of benefits from doing this. The generic option is Subversion. It does a lot of the same things that GrabCAD does in terms of being able to check out and check in parts. It's not designed specifically for CAD. It just works on kind of file systems in general. And then the 3 major CAD packages, Autodesk, Solidworks, so Autodesk Inventor, Solidworks, and PTC Creo have their own version of file management systems. Vault for Autodesk, PDM for Solidworks, and then Windchill for the PTC products. They require you to set up a server, but they're specific for your CAD program, so they have integrated options in terms of being able to know certain things about what kind of part it is, whether it's an assembly or a part file, etc., and make certain decisions for you based on that. So if you're looking at the server option and you're using one of those CAD packages, I would definitely recommend checking out the associated version management software that comes with it. And all of those programs that I just mentioned are the CAD packages are free for FRC teams, and we'll talk about how you can actually get those later. But the versioning software, I believe, is also free, or at least it has been in the past. So for students and educators working with FRC teams, this is a pretty cool option for you guys.
Mm-hmm. Yeah, and then one thing to note here is if you're watching this presentation or watching this video and you haven't gotten started with CAD yet, then just don't worry about option number 3 yet until you're very familiar with the CAD program and it's gotten to the point where cloud storage and GrabCAD don't do what you want. One way to think about it is use cloud storage until you find out that it's limiting you, then use GrabCAD until you find out that it's limiting you, and then move on to your server-based solution. As you're just getting started, a lot of the issues that we mentioned before, you're probably not going to run into until a little ways down the road. Click. There we go. Option number 4.
This is your slide, Ty.
Oh, right. Got it. So, option number 4 is CloudCAD. It's 2017. Things go in the cloud now, and that is true for CAD as well. So we have OnShape and Autodesk Fusion 360. Both of these are programs that are run almost entirely in the cloud. Fusion 360 actually requires you to download an application to use it, but all of the data is stored in the cloud, and basically you're just doing an application so that the computer can do all of like the heavy work on your computer, and then all the information is synced with Autodesk's servers, and basically someone can pull up information from another computer as well. So then OnShape, it works entirely within the browser. Basically, it uses your browser's graphics acceleration software or hardware acceleration that it's allowed to use, and you can just basically just do the CAD in your browser. So these require the internet to use, and it handles all, but the important thing is it handles all version control natively. So you can roll back to a certain point in time to see how things go. You can actually you can make branches, so you can get to a certain point in your CAD and then split off left or right to explore different things, and then choose which branch you want to eventually use. And a good way to think about these is the Google Docs for CAD. You can have multiple people working at the same time. It automatically saves it. It's pretty great, but they do have their limitations that we'll get into in the next few slides. So to summarize, you've got the three solutions here in extending or in increasing complexity yet flexibility, and then here is the option where everything is just magically done for you in the background like any Apple product, and you're basically just you use what they give you, and what they give you is pretty nice too.
So you've heard us talking about these various different programs. Let's get into it. Autodesk Inventor Professional Autodesk is a big sponsor and supporter of FIRST, and they offer their product, specifically Inventor Professional, to FIRST teams and mentors that work with them for free. So you can go to their education free software page and you sign up for an account. You fill out some information. You basically say what team you're working with, what school you're working with, blah, 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 blah. And boom, there you go. Now you can go download the software. So some of the pros of Inventor, some of the great things about it, it has some really great native design generators for chain and belt and fasteners and things. So if you're using that, it's got some pretty awesome tools built into it to help figure out exactly what size chain and belt you want to be using, or insert fasteners into your model automatically and figure out all this great stuff about them. Another cool thing about it, if your team works with CNC machines, it has HSM Works, which is the CAM program that developed by Autodesk. And that's already embedded in the software. So, for example, on Apex, we don't use Inventor for most of our CAD. We use OnShape, and we'll talk about that later. But when we go to our sponsor's site to machine parts, because they let us use their machines to cut parts on their CNC, we have to generate the CAM programs ourselves. So we actually go get Inventor on a couple of the team computers, and we take our models out of OnShape and use HSM Works in Inventor to develop our CAM programs, and then we can go make our parts on the CNC machine. Some of the downsides is it's a large install, right? This is a multiple gigabyte program. We already mentioned the system requirements up above. It takes a lot of hard drive space, and it is resource intensive. It takes a pretty beefy computer to be able to open and run a full robot model without crashing. Go to the next one. I think that's all I have on Inventor, unless you have anything.
No, I have absolutely no knowledge of Inventor.
I guess this is probably a decent point to mention that at some point in my first career, I've used pretty much every major CAD package, from SolidWorks, Inventor, OnShape, what used to be Pro Engineer and is now PTC Creo, and then I've also used CATIA professionally. So there's a lot of different software packages out there. Mm-hmm. They mostly do the same thing. They just have slightly different interfaces and slightly different features.
All right. So let's talk about how SolidWorks does the same thing. SolidWorks also offers a free version to anybody in an FRC team. So the way it works for them, however, is you sign up and you get a license for approximately a year, and you can get as many licenses as you need. And each license, I believe it's one license per computer, and you go in, you sign up, and you get the download links. You download it. It's got the same benefits of available integrated CAM, but it does have a simpler interface than Inventor. They've been refining SolidWorks for quite a long time now, and it's pretty much the leader in terms of non-specialized CAD programs. There are CAD programs that are much better at very specialized things, but if you're looking for a generic CAD in the mechanical engineering industry, SolidWorks is probably what you're going to find. So what that really means is that you're going to have a lot of support from other teams and exports. If you use SolidWorks, you're going to find that most of the CAD community in FRC has used SolidWorks or knows somebody that has. So SolidWorks might be where you want to go if you're thinking that you're going to need a lot of help on the way. It's probably going to have the most resources available right now. And it's got the same cons as Autodesk Inventor. It's a large install to work. It takes approximately 40 minutes to install. It's resource intensive. And one of the things that you have to consider with both Inventor and SolidWorks is that actually installing these things can also be a limitation. And if you're working out of a school, those schools actually have restrictions on who can install what on school computers. So you might want to take that into account when you're deciding which type of CAD program to go with.
Yep. At the same time, especially with SolidWorks, Inventor, and I think we talk about PTC Creo next. If your school is already offering CAD classes, a lot of schools, high schools do offer some basic CAD classes. I'd heavily lean towards picking up that program for your team, just because you already have that support at your school, and as well as the tech support, the IT people at your school. Are familiar with the program and are probably more willing to get it installed on school computers.
Mm-hmm. Very good point. All right, now on to what I'm sure you have guessed is my favorite CAD program for FRC, is OnShape. So Evan, go ahead and let's talk about OnShape. I'm pretty sure we're both going to chime in quite a bit on this slide.
Yeah, so both 319 and 5803, I think we both switched last year, right, for 2017, to using OnShape. Previously, Apex was using SolidWorks, although that was almost accidental. But we made a concerted effort to get some students trained in CAD last year, and we chose OnShape for that. So where do you get it? It's a pretty simple link up there, edu/FRC. They are supporting FIRST. As of last year, they had the field model available in OnShape, and you go sign up for an account. There's no install. It's cloud-based. It's in your browser, and you just go to the website and open it up, and boom, there's your CAD program. So that also means, as we mentioned before, it saves things instantly. I've had my browser, while using it, crash in the middle of doing a sketch. And when I opened it back up, that sketch was still there at approximately the point where the program crashed. So I didn't have to worry about always making sure that I saved my progress. And it's got the built-in version control, as we mentioned. It also has a phone app, which I don't recommend you actually CAD on your phone. But it's really great for being able to look at things, show people things, especially if you're, if students are working on a model, maybe during lunchtime or before the meeting, and you want to see what your friends or if you're a mentor, see what your students are working on. That's pretty awesome. And it supports multiple users in the model at the same time. And we're talking like literally in the same part. Somebody can be working on one feature and somebody can be working on another feature. That's a bit of an extreme example, but it's something that it does support.
Yeah, and we haven't found a ton of uses for modifying the exact same part, but we have found uses for, people working to put together an assembly together. But one of the biggest things I've found is there's a follow along option that you can use, and you can basically, I can log on. I live in Massachusetts and mentor the team in New Hampshire. So I can log on from Massachusetts and follow along as they do CAD and mentor them and say, oh, no, I meant to put the hole on this face versus that face, or change the size of this hole. It's a really good educational tool there. And then one of the super big things that I really like about OnShape is they have some real novel ideas. As we've said before, a lot of these CAD programs are pretty close to the same. But OnShape is kind of breaking that trend with this multiple parts in one studio option. Instead of in SolidWorks, you would make one part per file. But here, you make a part studio, and then you make all of your related parts, or even all of your parts, in one studio.
Yeah, it's pretty cool. This is something that in a more traditional CAD program like Inventor or SolidWorks, you just wouldn't do, because the risk of completely breaking your model. And when we say break your model, we're talking about like it throws all kinds of errors at you, and then you have to kind of take a lot of time and go back and fix each thing step by step. And sometimes you have to go recreate whole parts. So stuff that would traditionally just be a complete no-no is really well supported here. Now, the downside is you need an internet connection at all times. So, if you're at a school where you don't necessarily have access to the internet all the time, or the computers at school are restricted and you can't get to OnShape, and students don't have access to the Wi-Fi, that can be a challenge. And then there's also some standard features that are missing or not implemented yet. They're always adding stuff, but for example, sheet metal capability didn't show up in OnShape until like the middle of the season last year. And then they don't have support for custom weights right now. So if you're trying to track the weight of your robot in OnShape, that makes it a little more challenging. We ended up having to go use a spreadsheet because we can't say, oh, the sim motor weighs this much. You just have to know that the sim motor weighs that much and find out the weight of the custom parts that you're making.
All right, now there's other options other than the three main ones that we've listed. Autodesk Fusion 360 has free versions that you can use for students, teachers, and educators. Autodesk Fusion 360 also has their CAM built directly in as well, so you can kind of go straight from CAD to CAM. It's a very powerful cloud-based program. You've got Creo by PTC, which you can again get for free. That is something that I am completely unfamiliar with. Evan, do you know how many teams use Creo? Evan, you're muted.
Sorry, I muted to stop the dog from bleeding through. Stop myself. I know a handful of teams use it. I believe 118 used to use it. They might still use it. A lot of it is just whatever the mentors of a team are familiar with, or whatever company that's sponsoring it supports. If they use PTC, Creo used to be called Pro Engineer. As far as, it's pretty much similar to the rest of the programs. The interface is a little less intuitive, but it can be a much more powerful program. They have some really nice features in there, but and I think they've got a lot of built-in simulation for like kinematics and things.
And then finally, we've got SketchUp, which is kind of your bare bones CAD. It's free. It's free to anybody. You can throw simple prototype ideas in there. It's really not designed. It's more designed for like an architecture kind of standpoint, but you can make it work for simple parts and simple ideas within the FRC. You're really not going to be able to like import models from a vendor. Like if you got a model of a shooter wheel, you wouldn't be able to import it to SketchUp, but you could come up with some pretty good like relational, spatial relation ideas going on in Google. All right, resources.
Yeah, so here's a handful of really good resources. Whether you're just getting started or you're trying to learn more, get more proficient in it. We've kind of broken this down by program. I will note that a lot of what's contained in here is applicable to multiple programs, especially between SolidWorks and Autodesk. Again, the interface is different, but the core functionality is fairly similar, and so a lot of the lessons that are being taught here are applicable to both. So don't assume that you can't look at 1114 or 973's tutorial series just because you're using Inventor. And similarly, we list Solid Professor, but they really offer curriculum online for pretty much any CAD program, including OnShape, which I didn't even know about until I went to go look at it before this show. It's free for FRC teams. I don't know if it's a kit voucher or if you just go sign up there, but definitely a really great resource, which you can check it out. The other thing that we'll mention is most of these programs come with some basic tutorials, and that's always a great place to start, especially if you're really beginning at CAD, because it's not only going to teach you the interface that you're working with your program, but it's also going to kind of walk you through the very basics. So it's not going to teach you the more advanced features, and it's really not enough repetition to get to become proficient in the program, but it's going to get you started, and that's a really big part of it. And then, as you can see at the bottom, there's some OnShape tutorials and Fusion 360. NYC CNC has some tutorials for that as well.
So now, one of the things that's important here is CAD creates digital 3D models, and those digital 3D models, there's actually a few formats which are kind of platform independent and can be imported into any of these CAD programs that we've talked about already. And those are step models or IGES models. And you're going to lose some of the features. It's basically just going to be the final 3D shape of what you designed. If you were to design something in SolidWorks and then export it as a step, you would have just the 3D shape that you ended up with, not like you wouldn't be able to go in and modify the underlying sketches that ended up defining that shape. But these things are really good for companies to help by providing CAD models for use in your models that you're designing in FRC. So we have vendors like VexPro, AndyMark, Cross the Road Electronics, West Coast Products. They all have CAD models listed alongside of their products. You can go on VexPro and you can download a Versaplanetary model, and you can download the motor model, and then you can go to Cross the Road Electronics and download a motor controller module. And West Coast Products, you can download all of their gears and sprockets, et cetera, and you can basically take exactly what you're thinking about buying and stick it into your model and see how it fits. Then to extend that a little bit further, the Blue Alliance has started hosting CAD models of teams by year. The Blue Alliance has the Blue Alliance basically linked up with GrabCAD and uses GrabCAD's API so that teams that put their models in GrabCAD can link them on their TBA page. So if you follow this link in this document, then you can see a list of 2016 teams that have CAD models on TBA. Now, the kit apart and game-specific models are provided every year in step format, OnShape format, Solidworks format, Inventor format, anything to make it more accessible. And that's on the kit apart webpage. And then 3847 has been making a very nice GrabCAD library where they've already kind of gone and downloaded the vendor models and moved them into SolidWorks for you. And you can import that and use it automatically inside your model. Now, these are just the FRC specific models. The non-FRC things is you can go to GrabCAD and you can search for models of like a kitchen stove or a Bridgeport or a graphics card if you wanted to CAD your CAD computer, which is pretty meta. And then other vendors also provide CAD models. For example, if you went on McMaster and you wanted to find a specific screw that you wanted to use to make sure that it was long enough or short enough, then you can download that. And McMaster is actually really great for providing a CAD model for almost everything on their online store.
Yeah, there's very few things on McMaster that you can't download a CAD model for. And that's really cool to be able to go and say, oh, I want to use this spacer, I want to use this bolt, I want to, snap rings. I'm trying to remember what we've all grabbed from there before, but pretty much anything you want, you can go download it, bushings, bearings, etc., and import it, and there you have it. You can make sure that it fits in your robot where you want to.
Mm-hmm. So these are all things that make your CADing life a much easier. If you get a basic understanding of CAD and you know how to make, aluminum tubing and get it to the right length and put holes in the right spot, then basically you can mount VexPro, AndyMark, and West Coast Product things to that. All you have to do is download it, figure out where the right holes are, and you're off to the races. So finally, we've got some tips and tricks here.
Yeah, so we didn't spend a whole lot of time talking about what sketches are, but when we talked at the beginning about using 2D layouts to figure out stuff, most of the time those are sketches. And if you want to make a 3D part, you start with a 2D sketch, and then you'll use an operation. Either you'll spin it around an axis to create a volume, or you'll extrude it in a direction to create a volume. Sketches, whether you're using them for your 2D layouts or to make 3D parts, you want to be using relations in your sketches. Those are things like this line needs to be equal to that line. The circle needs to be equal to that circle. These two parts should be horizontal. These two circles should be tangent. Stuff like that is what makes CAD so powerful, because it captures exactly what you want, makes the model flexible if you change your mind later, and takes care of all of the math for you. You don't have to figure out exactly where the center of the circle needs to be relative to the line to make it tangent. It just is. So you want to, CAD is a tool, and you want to make the tool work for you. Along the same lines with sketches, a sketch isn't done until it's fully constrained. Each different program has different ways to indicate this, but in general, If you're making a part, you'll start with your 2D sketch, and until it's fully constrained and you can't click a point and drag it around anymore, you don't want to move on from that, because you can think that you have something that's a particular dimension, and if it changes later, you might not notice. So make sure that you've defined everything about that first. The only exception to that is if you're using a layout sketch to like figure out the kinematics of your robot. And so you want this arm to move along an arc or something, and then you leave it undefined in that degree of freedom so that you can click and drag with your mouse and make that arm move where you want it to go. One thing that, you know, a lot of teams are like, oh, we can't do CAD. We don't have time to CAD a whole robot. But you don't have to CAD your whole robot to see the benefits out of it. A lot of teams only do a 2D layout, get their critical dimensions, figure out where they need to put axles and shafts and exactly how big things are going to be, and then they just start building it, right? And that's you know, if you haven't been building with CAD before, this is a really easy way to get started, to try and save yourself some time and some heartache without completely upending your whole build process, because you're used to just kind of cutting material and figuring out where it should go, and just building a robot as you go. We mentioned earlier Hot Team 67. For the longest time, and they may still do this, they designed their whole robot basically as a series of 2D sketches. They never did a 3D model. You know, and this is a multiple world championship winning team. They're really good. You don't have to use CAD to be good. But certainly the power of the 2D layout is pretty evident. And then one thing that I know a lot of teams like to do is to do space claim or block CAD, which is where they're not doing details. It's kind of halfway between a layout and a full CAD, but they're doing 3D spatial integration and making sure that all of their mechanisms are going to fit, or just, you know, saying, well, we don't know exactly what this mechanism is going to look like, but it's going to fit in this box. And so the rest of the robot has to not go into this box, and put a box there in their CAD and say that's for the, you know, that's for the mini bot mechanism, that's for the climbing mechanism, whatever you want. And the last thing is just, you know, with anything, practice a lot. You don't get good at CAD from watching a lot of tutorials and then just trying it once. You get good at CAD by doing it over and learning how you like to do CAD and starting to understand, you know, make the connection between what you're doing and how it translates to the real world, and just get better. You know, I didn't learn a lot of these tips and tricks until like a year or two after I started doing CAD. But eventually you'll start to understand how CAD can help you, and you know, the more time you invest in it, the more beneficial it'll be. Ty, you got anything else to add before we go to questions?
No, I think that pretty much nails it. The important part here is, you know, watch the tutorials, follow along. I think one of the biggest tips I would probably give is to do something that you're interested in at first. Find something simple to CAD that you have an interest in yourself while you're following along. It makes it a lot easier to, you know, go through any frustrations that you could possibly run into. One of the, you know, I wouldn't say, you know, I could say you could probably design like some simple linkages, or maybe the frame for a drivetrain, or a very simple single speed gearbox. I wouldn't go anything crazy like a flipped 775 Pro shifting 3-speed gearbox or something. But yeah, find something that you're passionate about, and it'll really help you. It'll go a long way towards getting you through those frustrations if you ever run into any.
Yep. I think one of the first things I did back in 2005 when I first learned CAD is I went and I pulled a Van Door motor out of our kit of parts, and I was like, you know what, I'm gonna make a CAD model of this, and I did, and that was it. Right, you're just sitting there with some calipers and whatever, and make a model of a physical part that already exists, and you know, that's a great way to learn. I'm not necessarily trying to bring all of the design aspect into it with everything that's involved with making decisions. I'm just learning how to use the tool to make something that already exists. So that's something that I can personally recommend if you're just getting started and aren't sure where to start.
Mm-hmm. All right, so that concludes our presentation that we have here for for getting into CAD, we've got a few questions coming up from our audience, so we'll get into those first. The first question we have available is from Pongo. Pongo says bark. It seems it's more of a statement than a question, but we'll serve it anyway. All right. So our first legitimate question that we've got coming up is, what program do you use for CAD? Coming in from Baby Haley 01. Evan, you can go first.
Sure. Well, so we blah, 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 blah. We mentioned it a little bit in the show. Apex uses OnShape as of last year. We really like it, mainly because we don't have any formal CAD curriculum at the school that we work at. And so it was, as Ty mentioned, a really easy way for us to teach students how to use CAD, especially to be able to sit in the model with somebody and say, you know, I'll be working on a part and they'll be working on another, maybe something a little bit simpler. And if they get stuck, they can just ask me, and I'll be able to help them out. We did some Skype calls while we're working on CAD. But before that, we used SolidWorks, and I think, as you know, Ty mentioned, that's a pretty common program that I really like. The big hurdle is just getting it installed and doing any kind of version control.
Yeah, that's the biggest reason why 319 switched to OnShape is basically any computer that has internet access that the school hasn't restricted onshape.com, then you can jump on there in CAD. You can have, one of the really big benefits is that OnShape kind of works with the lower resource computers, and that's really great because basically any computer, whenever we're at the school, any computer that we have access to, we can just jump on and start CADing, or we can view things. One of the really cool things that we kind of accidentally stumbled on is we can make drawings at the computer, and then the kids can pull up their phones as they're standing next to the machine and refer to the drawings on their phones instead of having to print something out. And then if we do want to change dimension, we change it on the computer and it'll come up and it'll change automatically on the phone's app. We really like that. We really like the ability for multiple people to edit the model at the same time. And we're a big fan of how easy it is to share. It's like Google Docs. You just invite somebody to the model and then they can view it. They don't have to install the software. They don't have to install the software. They don't have to download it. They don't have to get connected to our GrabCAD or anything. They just click the link in the email and boom, they're looking at the CAD, which is really, really, really great. And basically we've started using it to extend outside of our group and kind of just put it out to the world wild web and say like, hey, check out our CAD. Do you have any comments or concerns about this?
Yeah, I think the one last thing that I'll add, we did mention it as a bit of a downside earlier on very briefly, but the fact that OnShape doesn't have all of the full controls for weight, I think has been the biggest thing to get used to, because I've been used to in SolidWorks or Inventor just being able to set weights for all my parts, and you make sure you do your due diligence up front, and then you pop out a robot weight at the end, and it's pretty much accurate. And so, having to track that separately in a spreadsheet. But if you're not using CAD already, hopefully you're already doing some kind of weight estimation or weight tracking in Google Docs or in Excel or something. So that transition probably shouldn't be as hard as it was for me personally, going from having all of that fancy features to not. And hopefully they'll add that in the future, but right now it's not there.
Yeah, and you can actually get really, really close weight estimates. For example, if you download a ball bearing model from like McMaster, you can set the ball bearing material to steel, and it'll be a really close estimate of how much that ball bearing weighs. The only time you really start to get into trouble is when you're doing like full assemblies, like a versaplanetary gearbox. It's difficult to assign to find a material property for that will get your weight correct. All right, our next question is it better to teach new students sketches or parts first or assemblies first? Evan, why don't you take this one?
Sure. It's a little bit of a personal preference. And it I think it really depends on how your team is using CAD. If you're going to be doing a lot more of the 2D layout stuff, or if you only have like one student that's really working on it, I would really start with sketches. I think that's a lot easier way to start introducing CAD to a team. If you already have, if you're already using CAD with your team, or you have a large number of students who are interested in doing it, and especially if you put a lot of heavy use on COTS components, from VexPro and AndyMark and West Coast Products and those kinds of deal. I really like starting with assemblies when we teach the students on Apex, because it's a really easy way for them to get involved quickly and have a really big impact on how quickly we can get our CAD models done, without needing to kind of go through a lot more of the nuances and a lot more of the sort of geometry stuff that comes with the sketches. So it's a little bit of a non-committal answer. I prefer teaching assemblies first, but that's basically because we have either mentors or students who are proficient enough in the sketches and parts that that's already covered mostly.
Mm-hmm. Yeah, assemblies is a very good way to get familiar with the CAD interface. I think there's a lot of overhead when you're thinking. There's a lot of overhead in your thinking when you're working with sketches and with parts, in that you have to think about, okay, how am I going to build this part? Whereas when you're working with assemblies first, you're just thinking, okay, I have this part. Where does it go, and how do I fit it into the puzzle piece of my assembly? And I think that's a very good way to just kind of dip your toes in, get familiar with the interface, get familiar with moving around in the CAD program. And then when you move into assembly, or when you move into parts and sketches, that's where you actually have to start thinking as like a designer as well as a CAD user, which kind of helps us transition very nicely into our next question, which is, how do I learn to be a good designer? So I think there's two ways to do this, and it basically applies to how do I learn to be a good anything. And that is A, find someone who you think is really, really good at it and just ask them a bajillion questions. And that it doesn't have to necessarily be a person. It could be Chief Delphi. You could ask a bunch of questions on Chief Delphi. It could be a bunch of teams. It could be you could just throw a bunch of questions out on Facebook, or it could be someone that you find out to be an expert and ask them a bunch of questions, and if they're in FRC, they'll be very willing to help you. Then the other option is practice. You're never going to be a good designer if you don't trip over all of the mistakes. The only reason that I know that I need to make my bearing holes a couple thousandths bigger than the actual bearing sometimes is just, smaller, is because I made them the right size, and then it got all sloppy. So the only way that you're going to become a good designer and avoid mistakes is to make those mistakes. So get out there and start tripping.
Yeah. Interesting use of words there, but yes, definitely, making mistakes is part of the process. I think the way that I like to explain it is that CAD is a tool, and design is about making decisions, and they're fundamentally kind of two different things, but you can use CAD to help you make those decisions. So the way that you become a good designer is not necessarily by becoming a good CADer, but it can certainly help you, because it can help you try a lot of different things and learn what your decisions and what your choices are going to impact later on. And then the biggest thing, kind of along the theme with making mistakes, is make sure to be involved. If you've designed parts in CAD, make sure to be involved with the actual building of those parts, the fabrication, the cutting, and the assembly of those parts, because that's where you're going to understand and start learning how the choices that you made that then got reflected in CAD are actually affecting the physical world. And so that's how you kind of close the feedback loop on that. But ultimately, being a good designer is about making good decisions and making good choices and understanding the reasoning for making various choices. And the only way that you can do that is either by taking somebody else's advice because they've done it before and done it wrong, or by making mistakes and learning, what the impact of that choice is and making a different choice the next time.
Mm-hmm. All right, we've got one final question here from our question MVP of the evening, Haley. And up it goes. How long is Autodesk free for if you do it through FRC? So one thing we mentioned is that Solidworks is free for about a year, and then you renew your license. And Baby Haley's asking, is that true as well for Autodesk, or is it different?
I think it's the same. At least I remember having to reinstall Inventor a year after, because the free license expired. But don't quote me on that. But yes, it will be at least for a year. And then if you're still involved in FRC, good news, you can go back the next year and get the next version. And you don't have to get the next version. You can just get a license for the same version. I know some teams like to stay on the same version for multiple years, just because it makes backwards compatibility not a concern. Because sometimes you can, if you change to a new one, everybody has to change to the new one. But for the most part, it will be free for at least a full calendar year, not an FRC season, but actually a full 12 months, and probably a little bit longer than that.
All right. Well, that is how to get started with CAD from me, Ty Tremblay on 319, and Evan Morrison on 5803. We thank you a lot for joining us here on BTL. Evan, why don't you send us off?
Cool. Well, thank you all for joining us tonight. Behind the Lines is co-produced by RoboSports Network in official collaboration with FIRST to provide some really awesome resources. So if you haven't seen any of our other episodes, definitely make sure to go check them out. They're all hosted on our YouTube as well as on the First Inspires website. Our next episode is in 2 weeks on November 29th, and we're going to be talking about designing your robot for manufacturability and utilizing commercial off-the-shelf parts. So we talked a little bit about them tonight. We're going to talk a lot about them in 2 weeks. So don't want to miss it. Make sure to follow us here on Twitch or on YouTube, as well as on Facebook and Twitter, to make sure you get the updates of when the episode's going to be and who our experts will be. And then last but not least, we've got, as mentioned before, we've got over 20 hours of video on a broad range of topics, youtube.com/RoboSports Network. Thank you all for watching. On behalf of Ty and myself, good night.